Welcome back, enthusiastic learners, to the day 8 of our Machine Learning and TensorFlow Bootcamp organized by GDSC SNU in collaboration with Skepsis. Excited for the week 3 hands on workshop based on your ML project? We have with us today Arka P Chakraborty, who is the machine learning lead of GDSC SNU and above all, an ardent ML lover and learner. I would like to hand over the session to Orkoda. Thank you.
Okay. Hello, guys. Good evening. And this is. Am I audible?
Yeah, you're audible.
Okay. Fine. So, yeah, as you have known that this is the last week of our session of this bootcamp. You have learned about machine learning, computer vision related projects. Now, this is the last week. We will be learning about TensorFlow and about some terminology and some knowledge of deep deep learning things. So let me share my screen first. Is my screen visible or not? Let me know. Purnima?
It is visible, Dada.
Okay. Thank you. So see, TensorFlow is nothing just a framework of Python. It helps us to used in like deep learning. Okay, and something in NLP, object detection, face face recognition. This whole task can be performed by deep learning. Okay. So for this kind of processes, we need a framework that is TensorFlow. And we also have another framework that is PyTorch. But for now, we will be considering this for our today's session. So when deep learning term comes, the first thing in our mind is like neural network. Okay. So what is neural network? Like, just a minute. Okay. If I know my drawing is very bad. If this is my eye, okay, this is my eye, and currently I am staring at my screen, right? So what will be okay? Okay, so this my eye is gathering some data, right? But how my mind will be able to understand? Yes, this is a monitor or a screen, right? So this data, when this data is gathering and the data should be processed, right? By that processing, my brain will be able to understand like if yes, it is a monitor, right? For that, what our human beings does, like for that there are some neurons, right? Okay, my handwriting, my drawing is also bad. Pardon me for this. Okay, no, sorry. Okay, just think about this. Okay. So for that, my data should be processed by what? By my neuron. After that processing, process our brain decided, okay, this has some screen, okay, this has screen, and some stands are there, right? This stand. So these are my features, right? So based on these features, my brain will identify, yes, this is a monitor, right? Am I audible? My electricity is gone. I don't know. Let me see. So this is how human brain is used to understand our like neural network. I know this is a very complex thing, but I just tried to simplify this for you guys. So this is how human being does, right? So how we will be able to implement this thing in a computer level, right? So for that, let me consider some like value. Okay? Some data sets like study. This is my data set. Okay. Study, play, and sleep. And there will be some value of pass or fail. Okay. So let me consider this as my study has 7, plays 2 hours and sleep 6 hours. Then he might pass, right? And if he or she study for 3 hours and play for 8 hours and sleep for 5 hours, then he or she will not pass, right? Just mostly nothing. Okay. So when neural network comes in our mind, so first thing is like, so what neural network looks like? For that reason, I will use like single perceptron. Single layer perceptron is a very basic neural network, and it will be easy to understand than other neural network. So if my data are like this, okay, I will tell about this also. Just let me do. So you might ask what these round circles are. This is nothing but my features. My study, play, and sleep. These are my feature. These called input layers. This called input layer. So so this is my input layer. This is hidden layer. This is output layer. So what like the if I connect this neuron and this neuron and this neuron, this is nothing but just our data sets, like means features. Sorry, this is our features. And what how to calculate the features based on that I will consider, okay, this person will pass and this person will fail. So what our neuron does actually, or how the calculation is done, I will not go into the deeper part of the calculation, but for now, for simplicity purpose, I will just give you a overview. So for every neuron, we have to assign a weight value. Okay, so this is my weight 1, weight 2, and weight 3. And what will it does, like we have to summation in this neuron. This is my hidden layer. Okay, this will do the everything for these features, like the calculation part. So what will it do? Summation. First thing it will do summation of x of I and w of I. And what the next thing will do is activation function. Activation of, if I considering this as y, so this will be y. So now you might ask that what is weight and what is activation function is. Just for now, just understand the things and let me explain the things for you. The if something, if some hot object, if some hot object touches our skin, what we will do? We will just replace drop this object, right, drop that object from our skin. So if the hot object touches that area, only that area, that neurons will be activated for that time, right? Not our entire body neuron will be activated for that reason, for touching a particular area. So for as a human being, that hot object was our activation function. For that, we will just change our hand position, right? So for this neuron also, this weight value and this activation function will be doing the same thing. So what that summation of xi and wi means? Xi, if you consider, this is my data sets, x of I, x of 2, x3. Right, this is my data sets. And let me write this x1, x2, and x3. So what actually it does, like it will summation of, right? Summation of x of I and w of I. There is no such like big mathematics. So we have to multiply and summation. So that means x of 1 into w of 1 plus x of 2 into w of 2 plus x of 3 into w of 3. This is a very basic neuron model. After that, the activation function comes in the picture. So what is activation function? Activation function will do the will act for the activation of the neuron. So what is the activation function? Do you have any idea of logistical regression? Anybody have any idea? Logistical regression. Your voice is cracking. Okay, no idea. So, like linear regression, we used to draw a line, right? For logistical regression, we have to classification. Like this is a regression type only, and this is a classification. For this purpose, we use this type of line instead of this type of line. This is called sigmoid function. For the sigmoid function, we get this line. So, like for linear regression, where the equation was x plus c, for sigmoid equation, the cost function will be 1 by 1 plus e to the power minus z. Let me just erase the unnecessary part. By that you will be able to understand clearly. So this is my sigmoid function. Sigmoid function used in logistical regression. If you just search something about this, you will be able to understand what is sigmoid function. But for now, you don't have to worry about it. But because there is no such thing will be applied for this, just you have to pass the summation this part, this summation value to the sigmoid value. So it's sigmoid function. What that means? Like 1 by, this is my function of sigmoid function. This is my sigmoid function. Sorry. So this is my, if this is my function, what will be my value? E to the power minus summation of x of I, w of I. Right. So why we are considering this as a classification problem? Because see, if if a student can be pass or fail, right? There are two class. A student can be pass or fail. So that means we are having two classes. One is true, one is false. You can consider this true false, but for now pass and fail. So that means that you did you know what is binary? Binary. Binary means 0 and 1. So that's why we are calling this type of classification binary classification, because we have only two classes, one is 0 and 1, right? So for now, that's why this if you know the logistical regression part, you will be able to understand more clearly. But for now, don't you don't have to worry about it. Okay. So now this is my activation function, but there is a problem. What is the problem?
Dada, we have a
What is the
question.
problem?
Arin.
Huh?
Arin, I think he just raised his hand. Arin, if you have a question, you can ask Dada.
If a network works in computer which consists of all the states of, not like states, no, not like just identify an object. It will be using like any fields. Okay. In natural language processing, the neural network is also used there. Even GPT is a higher level of neural network. Okay. Anything? Okay. Fine. So what is the problem? Like initially this weight value are equal to 0. That means weight are initially 0. So just think about it. Like if this is my value, Purnima, unmute, mute. Okay. So if my weight value is 0 and I am multiplying something with 0, so what will be the my ultimate value? That will be again 0. So 0 into x1 will be 0, right? So that is a problem. So that's why we have to add something like bias. So what is bias? Bias is nothing but a value we have to add with the summation value or the weight value. Based on our weight, we have to assign some sort of bias, right? So just think why we have to use the biases. The bias we have to use because the weight is currently 0. If you multiply something with the 0, the activation function will not work, right? If your skin doesn't if some hot object don't touch to your skin, why you will change your position of your hand, right? That's why we have to use some sort of bias. Bias is nothing just a value. Till this, is there any question? If yes, let me know. Any conceptual question? Okay, I guess no. How do you choose bias? Okay, you have to choose a bias based on your weight value. If your weight is something in lesser, then you don't have to choose a lesser bias value. if your weight value is very big, then see, you have to, the main thing why you have to use the bias to activate your function. So if you have a weight value, then the sufficient weight value, sufficient weight value, then the bias should be less value, right? So that's why you have to implement the value of the bias. And bias and weight values are initially defined by the coding, but after that, it will automatically change their values. So just give me a moment. Okay. So this is like bias, and so what is my ultimate function will be look like. Now this summation of xi and wi will be look like with the bias is this, right? This function will be into the sigmoid function. So what is my sigmoid function? 1 by 1 plus e to the power minus summation of xi wi plus e. So this is my ultimate thing. So that was it about like neural network. But yeah, we have to see something. Okay. Okay. So now I have two neurons in my hidden layer. Like as I have told you, you can take as many as you want in the layer, hidden layers, and as many you want to take neurons. So ultimately, the calculation will be doing inside of hidden layers neurons, right? And these are my feature, like input layer. So as I told you, this is x1, this is x2, and this is x3, right? Let me connect this each neuron. This looks like something like this. We have to connect each and every neurons. By that, if for some sort of value, for some x value, the value in the this neuron will be something different, and for x1 value, something in the say like activation function can be different. But for that reason, there will be some something different value. That's why we have to connect each and every neurons. Right? This is my output neuron. See, same things will be done like assigning weights value, right? Activation function will be doing this task, and the summation will be is doing this task. Like same thing will be happen in the output layer also. Now, this is why my your question can become yes, my hidden layer can have any number of neurons, right? But why my output layer has one neuron? Can anyone tell me why this has only one neuron? Any idea? Okay, bias will be assigned right after implementing some after some cycle. The bias will be assigned automatically, or you can like assign the bias in the first time based on the weight value. I can explain the things into deeper, but for now, if I go deeper, then it will not be covered in one session to make output compact. No, no, no. See, my output layer has like the, if I'm considering like the binary classification. Normally, if you have some, if you are like detect animal detection or like animal classification, sorry, animal classification, like dog, cat, and snake. So see, three classes will be there. So then my output layer will be having three different neurons, right? But for now, for now, this is a binary classification. That's why, like, pass or fail, dog or cat. If I'm considering dog cat classification, then there will be only one neuron in the last layer or the output layer. Okay, so what we are doing right now, like, we are assigning weight value, we are calculating the summation, then we are calculating the, again we are, there will be some weight value, then we are will be able to calculate the same activation function, then ultimately output. So we are doing this direction, right? Input to output, right? So this is called forward propagation. And if, just think, if my first, what was my first thing, my first dataset was telling, okay, if this has 7 and play as 2 and 2 hours of playing and 6 hours of sleeping, then that student will be passed, right? What if my prediction, my model predict is as 1, but my actual output is 0? Then what should I do? Like, my is my model not efficient enough, or what should I do now? So if you calculate the actual predicted output minus predicted, I'm just, for keeping it short, I'm just writing predicted instead of predicted output. Okay. So predicted and actual. So what will be my value? 1 minus 0. What is the difference? This is, the difference is 1. What that means, you have to always keep in mind, like, the difference between predicted and actual should be near 0. It should be near 0. That will be considered as a good model. But now what should I do? Like, as you have told you, like, initially weight was like 0, right? W was 0. Every was 0. And the bias value was going through as the activation function, right? So if I if I train this model based on this output, like, if you, like, if there is a child and if you scold him or her for something doing wrong, is he or she doing the same again? Not right now. So based on this, see, this is my current output. This is wrong. This is how much wrong? The loss factor. This is my loss function. Okay. This is my loss function. So loss function calculate how much accurate how my model is, right? So this is my loss function. Loss function still is the 1. This value is 1. So I have to minimize this value to like 0 or 0 point something. But I have to minimize. So for minimizing, for I have to train this model from this based on this output and what is my actual output, and tell tell my model, and telling the model like my loss is 1, I have to minimize this loss. What will it do? Like it will do like from this side based on my current output, it will train again and weight will be updated. Then my weight will be updated for this output. For this output my weight will be updated, and I'm going now from this direction, means output direction to the input direction, right? This called back propagation. And for how my weight will be updated, it will be based on my optimizer. Basically, in another term, my loss will be telling, like it's just a guessing, right? I have seen something new, and you guess the next thing, right? So my loss will be telling, like if my loss will be telling how much accurate my guess is, and my optimizer based on my accuracy, it will guess the next, means next iteration or the next value of the output. So this is all about like neural network for now, the basic concept of neural network, right? So as this is our project based approach, so we'll be learning this deep learning thing into a project based learning approach. So we'll be talking some necessary things which will be needed in my project. For that reason, this is that I have discussed about optimizer and loss function. You will be see in the upcoming time. So let me just go into the next point. So that was my neural network. So that was my okay. Okay. This is my neural network, a single layered perceptron. But this is the main concept. This is just a neural network. But you have heard about CNN, not NN, neural network. Neural network means NN, nothing is NN. But you have heard about CNN, right? So what is the difference between CNN and NN? Not like we are not going to discuss differences between CNN and RNN. Sorry, NN and CNN. But what is convolutional neural network? What is convolutional layers? What is convolutional neural network? So for that reason, I have to showcase something like if you have some image, right? How 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 computer see a image? Can anyone tell me how computer see a image? In which format computer actually see a image? You have done. No, 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 not 0 and 1. Yeah, array. Yeah, we have to change that array into 0 and 1 form for the computational perspective. But for that reason, let me okay. Okay. This is my this is a simple image of a sandal, right? This is a pixel version. Okay. And this is how a image looks like into my computer. A set of array, right? This is all our values. So for convolutional neural network, we have to divide these values by 255, right? For if you are doing this big array function, like 30, 35, 179. But why you think like why we should divide the 250 by each value by 250? You might think, right? So for that reason, just give me a moment. Give me a moment. Is visible? Okay. So those are my actually the pixel values, right? See, understand the things. Like if I'm considering this one, this one, this one, and this one, those are 0, 64, and 128 values, right? And after the second array, 45, 48, 192, sorry, 192, okay, sorry, 40, 192, and 144 pixel. What convolution layer does is like it just calculate for now this for okay. So this will just calculate the value of neighboring with the neighboring pixel values, right? So for now, my pixel this will be my filter. Like this filter. This is nothing. If this is my picture, right? And this has some values, right? This has some rows and columns. 1, 2, 3, 4, 5. Okay. So these are my values, right? So, so I have some values, right? For I let me just copy this 1, 0, 64, and 128. Give me a moment. 0, 64, and 128, and 48, 192, 144, 48, 42, 42%. Okay. So what my filter is? Filter will be a kernel, like the value of a matrix. You can take 3 cross 3 matrix or 4 cross 4. That's on your choice, based on your choice. For now, minus 1, 0, minus 2. Minus 1, 0, minus 2, point 5, point 5, 4.5, 1.5, 1.5. Okay. What will it does? Like for now, we have to apply this filter. This is my 3 cos 3 filter, right? 3 cos 3 matrix. And this is my image array. We have to apply this filter onto this like 3 cross 3 matrix. What will it does? Like it will change the values. It will change certain values, and for that, like if you multiply, like see, if you just multiply minus 1 into 0 and 0 into 64, like there will be some changes, like this is considering for this value, we have to go all through the pixels. If I'm done with this part, like for now, if I'm doing for the, if my kernel is 3 cross 3, if I'm doing for this part, right? So now I have to change my part, right? Then my so then my filter will be applied there. Okay. If these were my matrix, then my filter will be applied here. Same thing, this will traverse like this 3 cos 3 matrix will be here from starting from here, then it will shift one column, then it will just go one row. The entire image array will it traverse, right? And after traversing, what will it does? Like if you apply some filter on a image, what it does? Like it changes the look, right? It will change some features, right? It will change same thing, it will be happen, right? See this image. First image was like as shown in the left side. When you applied the this matrix in overall image, if you consider this is like 128 into 128 image, 128 into 128 means height and width is 128 pixels, right? So my this kernel will be starting somewhere from here, somewhere from here. If my image is
Koda,
okay, uh,
hello.
hello,
বলছি ক্যালকুলেশন পার্টটা আরেকবার বলবে, ভয়েসটা খুব ক্র্যাক করছিল তো ওখানটা একটু মিস করেছি,
okay, 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 ঠিক আছে
লাইক
কোন
ফিল্টারটা
ক্যালকুলেট,
বসানোর পর
আচ্ছা আচ্ছা ঠিক
ফিল্টারটা
আছে,
দেওয়ার পর এক্স্যাক্টলি কি হলো ওই পার্টটা। থ্যাংক
ওকে
ইউ।
ওকে ওকে। আমি খুব ডিপে আজকে চাইছি না, কারণ এরপর গোটা কোডটা বাকি আছে, ওকে। আচ্ছা, এই ক্যালকুলেশনটা রাইট,
ও আচ্ছা, জাস্ট মাল্টিপ্লাই হয়ে গিয়ে অ্যাডিশন হচ্ছে, আচ্ছা আচ্ছা
একদম একদম সিম্পল। সি দিস ফিল্টার,
বুঝেছি।
এই ফিল্টারটা তুই নিজে চুজ করবি, ঠিক আছে? নো সরি, তুই চুজ করবি না এটা। সি ইনপুট তুই দেখতে পাবি যে কম্পিউটার নিজে নিজে সাম সর্ট নাম্বার অফ ফিল্টার্স অ্যাপ্লাই করে নিজে থেকে, ঠিক আছে? অ্যান্ড বেসড অন দ্যাট আউটপুট we will be getting this type of output, like not for like for this is like just a one example. There will be several type of filters will be applied and several type of output will be there, right? This is called convolution layer, right? Okay, so I was okay, this was my 128 and 128 picture. If my this is my kernel, okay, 2 3 2 3, okay, this is my 3 cross 3. So this will be applying somewhere from here, then it will be shifting next 3, then it will be shifting all through the image, not just for this area of part. This will traverse all through the image. After that, it will change in the pixel values, right? As I have shown you in the image, this will change the entire value. So after that, we will be discussing about Just let me do. Okay, con 2D layer. This is called convolution layers, right? We will need this in our project today. And next, we will need like max pooling layer. And then we will need like flatten layer. Okay. So this was my convolution layer, right? Now, if you think I have some values, sixty-four, this will be around okay. See, if you just do like we have 128 pixel in height and 128 pixel in width, right? So this will be extracting all the features from the image. What are the features look like? Like if you considering this filter, some image will be altered from the actual image, right? So there will be some certain of values, pixel values. The change there will be certain change in the pixel values, but the pixel like the image size is very huge. So to reduce the computation energy, we have to compress the image. If we are giving 128 into 128 image, like in practical we are giving 256 into 256, that means 256 pixel in height, 256 pixel in width. So if you are giving this size of picture, so not you are not giving one picture, right? We are not doing like one for one picture. We are not doing the neural network or convolutional neural network. We are applying these techniques in thousands of images. As I have given you a data set, there will be 20,000 images will be there. So we are not doing in a single image. So if you are doing the single image for 256, the how many neurons will be there? 256 into 256 into 3. Now you might ask, what is the 3 value? 3 is nothing but the channel. We are doing this for RGB. RGB. This R for red, G for green, and blue. So there is 3 channel. That's why we are taking this as RGB value. So if you think for one image, the neuron value is this. If you think this, if you multiply this, you will get the value. So if you're doing the 20,000 image, how many neurons will be there? 20,000 into this value. There will be so many neurons and so many computation will be needed. So for this computer will not be able to do, right? So that's why we have to compress this image into some smaller factor. So what we do for that, like we have to take again 2 cross 2 matrix. You can take any other of matrix. I'm taking this 2 cross 2 matrix. So what we I'll do? So I want to take 2 cross 2 matrix and find, see the name max pooling layer. It will take the max value from this kernel. If you set this as take this value, is 2 cos 2. So what is the maximum value for this? So this will be maximum value 128. So my first value will be entered. So what will be my next 2 cos 2? This will be something. What is my maximum value? For I have 125, 45, 66 and 126. But what is my maximum value for now? 126. Okay, just let me add one more row. Okay. Again, I am taking this kernel and taking out the maximum value. See, this is 100. Again, I am taking this value, 2 cos 2 matrix, and the maximum, taking the maximum value. So this is, see how many row was there? One, two, three, four. Four row was there and four column was there, right? So this is my 4 cos 4 matrix. Now I'm getting 2 cos 2 matrix. See, I'm able to compress the image. So this will be again gone through the convolution layer. Again, there will be applied some some filters will be applied. Again, there will be some max pooling layer will be applied. Again, the image will be compressed. I'm not. This is like the smallest form factor. I'm just talking about generalized form. So this is how it works. Then after applying everything, like after applying everything, the flattened layer comes. For now, I am taking this my as a ultimate layer. Means after applying convolution layer, after applying cooling layer, I am getting this out. Right. So let me take this. Do you know we are working in the when we are working in ML or deep learning, we are working with the values of vectors, right? So like we are not able to work in like other form factor of values. So we have to make this make these values into a vector form. By that we will be using in our neural network. Yes, again it will be applied through the neural network. Then there will be, okay, let me show you just first. Okay, so this is my 128, 126, 100 and 200. So if I apply this flattened layer, if I apply this flattened layer, what will be my output? This will be like if you have done the vector is nothing but the matrix, but taking only one single column. So if you are taking this, so this is my vector. This will be fed into our neural model. So this is nothing but our features. One, two, three, four. How many features do we have? Four. How you can add many numbers of neuron. Okay. For now, I'm taking this. I'm taking one more hidden layer. After that, I'll be taking output. For now, if I'm classification of dog cat, sorry, if I'm this is a binary classification, so this will be my output. In this is my feature 1, this is my feature 2, this is my feature 3, this is nothing but my feature 2. Okay, this is 200, right? If I'm not wrong. Okay, so this is how my actual convolution neural network works for image classification. This is all about like convolution neural network. I have discussed neural network at the very first because this concept is like harder than this. You don't have to do this filter operation by yourself. TensorFlow is there for that reason. So, is there any question till now? As I have told you, what are the steps for how to get these values from the images? If someone asks you if you have to apply some convolution neural network, will you be able to tell them like how you will be able to do that? Yes or no? Okay, I've discussed the thing in simpler form. Let me know if you want to know anything. Again, it was tracking. Okay. Chandrai. Chandrai, can you tell them how neural network actually work or convolution layers work? Avantika, yes, okay. Okay. For convolution, first we have to maximum Avantika. No, no, no. For you have to first, okay, for convolution or like, okay, or you have to apply convolution layer, then max pull, then flatten. Yeah, this is like basic layers. Okay, you can add some. There are some more layer like dropout layer. I will not be taking for this. Will take much time. But for now, understand the basic things. First, understand the basic things. If you understand the basic things, you will be able to go and search things, and you will be understand those things also. But you have to first understand the basics. What is the basic thing? How it works? বাংলায় বললে বাংলায়, হিন্দিতে বললে হিন্দি, সব ভাষায় হবে, কিন্তু বুঝতে হবে। Okay, today I had lot least few parts listen from the YouTube video. Sorry, Dada. Okay, no issues, no issues. Okay, so it was quite a boring session, right? Like I have talked about this convolution layers, right? And max pooling layer. Now, this is like conceptual things. Like you see, oh, there is so much mathematics, there is so much calculation. But for now, let me show something for you guys. Okay, okay. Just give me a moment. Okay, is it okay? This is nothing but just a. Is my screen visible? Okay. Okay. This is nothing but just a number classification model. It is a 3D representation. Whatever I am told you during the session, like if I have to classify this, what is this? It's a 7, right? Okay, okay, wait. Let me correct. It's 2, right? If I draw this thing and I am to predict these things, right? So how my things works? See, this is my this is my input, right? Then this layer, what it does, see, this does some filtration, right? The value, the pixel values, see the dimensions of the images, right? The height and the width in the higher side, right? They they are doing the max pooling thing, right? The image is compressing, right? Then they are doing again some convolution or filter apply. Then they are doing the same thing again and again until they did the flatten the values. As I have told you, here my input actual image, my image, then they are applying some convolution layers, then they are getting some like max pooling layer, then they are applying again convolution layer, then they are max pooling again until they flatten, then they are doing the neural network, and ultimately what they get in the output. Okay, ultimately what they get in the output. See, these are also neurons, right? What I have told you, like, number of classes will be your output neurons. See, there, here we have 10 neurons. So, but my classification was for 2, number 2. For my number 2 is giving my output. See, this was like quite interesting presentation for newcomers in the deep learning. They can visualize the things. This is quite boring thing, like how the everything works. So yeah. Okay. So next thing I have, like, whatever I have told you in the theory session, there will be a practical example. There should be a practical example, right? Okay. So there will be, okay, reconnecting again. So everyone has downloaded the file, right? I have told you for that. Okay, okay. So for I sorry guys, I don't have today my stable internet connection. For that reason you might face some issues in voice cracking. I have downloaded but some glitch offered. Okay, no issues. Okay, okay. And after that you will have a assignment for this session. Okay. So if you have downloaded the thing, like the zip file, let me just get this access. Oh, will it work because of my internet connection? Okay. So it should be look like something this. Sorry. Okay, my internet sucks. Nice. Sorry guys for the bad internet connection. Chat. Sorry. You have to download and place this file into a folder, right? Like I have created this folder for now, and those things will be appear when you unzip this file, right? And whatever I have told you, I'll be implementing in this code and explaining everything. Okay, I have some issues with the internet connection. I will be giving this code also. Okay, don't worry. I've run this. Okay, wait a minute. Okay, do you want to go along with me, or just like I will be, then I will paste every comment in the chat and you have to apply in your collab. Hello. কোথায় সবাই ঘুমিয়ে পড়লো না? আছি আছি, ওকে। তো কি করবি বল, তোরা কি মানে অনগোয়িং করতে চাস, ওর আমি দেখিয়ে দেবো ফর নাও? আর এটা রিপ্লাই তো দে, আছি আছি সবাই বলে আবার চলে গেল। অনগোয়িংই করি, ওকে ওকে। নেট বাজে আমার, ওকে, নো প্রবলেম। যাদের অসুবিধা আছে তারা দেখ, এটা হ্যান্ডস অন করলে তোদের সুবিধা হবে, আর কিছুই না। ফাইলটা আমার ফাইলটা ডাউনলোড ফর লাস্ট কানেকশন চলে গেল, হয়নি সেশনের পর। ঠিক আছে, কোনো অসুবিধা নেই। দেখ, এটা কোনো অসুবিধা নেই, তোদের যেটা টাস্ক থাকবে সেটা সেশনের পর বলা হবে। আমি একটা গ্লিমস দিয়ে দেবো যদিও, ঠিক আছে? আছে, তো দেখি কি করা যায়, ঠিক আছে? So see, first you have to like mount your drive. How you will mount? So this is the code for that. This is nothing just from google.colab. This is small easy command. Now you have to go to that directory, means that folder where you have given that data set, right? .zip file. Okay, let me share this also. Okay. As you have told, সবার আজ সেম প্রবলেম, ন্যাশনাল ব্যাড ইন্টারনেট ডে। না, আমার ইন্টারনেট প্রবলেম কারণ আমি ফোন থেকে করছি, মানে ফোনের ইন্টারনেট ইউজ করছি, দ্যাটস ওয়াই। আচ্ছা, অ্যাকচুয়ালি তুমি আগে দেখিয়ে দাও, ওকে ফাইন, কোনো অসুবিধা নেই। সে আমিও দেখাতে পারবো কিনা বুঝতে পারছি না, জাস্ট গিভ মিনিট। ওকে, told you. See, this is the code for mounting your drive. Okay, then you have to, yeah, cd is like change directory. Okay, you will be learning these things like this command things in your OS operating system, like in second year, fourth sem. Okay, and ls command is for like what I have in this folder, whatever things I have in the folder. So let me run this command, and this is showing that this I have this folder, this file catdog.ipynd, and I have run this file before, like before the session, because I don't rely on my internet. That's why I have already run this before. No worries, I am explaining these lines also. Like this is command for unzipping that zip file. Okay, you can extract and took that train and test data also, but for safety purpose, because there if you do this that way, there will be some error can be occurred. That's why I'm telling you to, if you want to unzip that file, use this code. What this code means, like zip the file, the zip file location, how you will get this file location. Okay, let me show you. This is my drive, right? In my drive I have my drive is a default thing for Google Drive. Let me, as I have told you how to change this directory. Okay, I have not show you. If you go, like this is my folder, right? This is my folder. I have three dots here, and then you will get that copy path, right? You have to copy the path and the paste. See then paste the path. You will be able to get in this file, right? Means you are now working in this file location. Generally, if you if you start your IPYNB file, you will be directed in the home, means like in the drive location where every file will be there. That means that will be some unorganized form. That's why I've told you to follow this way. This will be in an organized way, and you will find all the files in our one single folder. That's why. So I'm copy this path. Okay, Then I'm going to the change directory. Means if you just see, my current directory was when I have mounted my collab. That time my sorry, my location was at my drive folder, right? So to change that folder location, I have pasted this command. Your command can be defined because of your folder name. Okay, so ls command is, I've told you. So now the unzip. How to unzip? So this is the code for the unzipping. So how to unzip this? The zip.zip file is nothing but the syntax, and you have to place the .zip file location where you will find this .zip file. Okay, this is my .zip file. Again, you have to copy the path. You have to paste in the quotation and the read mode. Read mode means reading your zip file. There are other methods also, write byte mode, WB. So, but now just reading you have to just read, right, to file extract all the files. Then extract where you want to extract in the same location, but in a I have created my folder at its name GDSC. That's why I'm giving this folder. See, your folder location name is very important, right? So now I'm closing the function. Okay. Chup. Import the TensorFlow data. This is normal. Like TensorFlow, I'm importing TensorFlow as TF. TensorFlow import Keras. Keras is a library of the TensorFlow, and sequential is a model. Like I'm not told you what is sequential model, but for now understand the code only. Like if you want to grasp all the thing, that is not possible in a single session. And I'm importing these layers like dense layer, convolution layers, and max pooling layer and flatten layer, right? So see, I have 20,000 images, right? If I am sending my images, 20,000 images at a single time, that means I'm pushing my images like 20,000 at a single time. So there will be huge computation power will be needed, right? So that's why we have to, like, batch size. We have to divide those picture into batches. Like how many images you want to put, how many images you want to give to the model at a time. I'm I have set it the value as 34, 32. So the normally you can take 64 also. Those values are like standardized values, 32 and 64. I'm doing this for train data. Now, for now, there's a advice for you guys. Don't understand a code from start to end. Like if you understand the main things, you will be understand these things also. These are not that much rocket science things. Like this is normal code. Nothing just will be there. If you see this keras.utils. This library, it has docs. If you search these docs, you will be get you will be able to get that each and everything for whatever parameter I have used there. See, this will be available in the internet, so you don't have to worry about it. So I'm changing the train value. See, this is very important. When you are unzipping the file, you will be getting this file like in this format. There will be one, two, three. Three file will be there. Test, train, and dog versus cat will be. I don't know what is this, but you have to work with these files also, right? So for train data, you are defining train data. Where you will get this train data? Like by default the batch size will be deferred. That's why I'm changing the batch size for now. So I have to give the train data location, same, copy path, and put your directory. Same thing will be here. You have to delete this, and you have to copy. Sorry. Okay. just a minute. If you do the same, and for trading data, see, I am doing this for you just to explain the things. When you you will be doing this thing, you might will face some errors also. That's why I'm explaining everything for you. So after that, you have to run the cell. I'm currently not running this cell because I have already run, and if I run this time, I will be facing some error. That's why. And the main thing, like as you have seen, like okay, see, this is my values, right? I have to normalize this value. Why I have told you, because if you have like multiplication, the convolution layers, so there will be huge value. If you multiply some values with 35, 179, there will be so many huge number of values. So that's why I have to normalize this value. What I have to do? I have to do nothing, just to normalize. I have to divide each pixel value by this 255. So I have done the same thing in the thing. You don't. You just have to. You just have to write and copy and paste this thing and then run. Nothing to understand for now. Okay. So now the main thing. This thing is called model architecture. You for now just stay okay. Concentrate for this part only. Before padding, okay, before this, you don't have, okay, these things also don't understand this for now. Padding, I've not explained these things also. So whatever I have explained you, see, for now I'm implementing first convolution layers. First layer, I've told you again and again, it will be implemented to compress the picture and extract the main features, right? Till now everything is clear or not? Tell me in the chat. I have to everything is clear? সিদ্ধান্ত চন্দ্রাই আর কি একজন ছিল, রাত্রিকা, ক্লিয়ার? আচ্ছা ক্লিয়ার, ওকে ওকে ওকে। দেখ, যখন করবি কোনো প্রবলেম হলে জিজ্ঞেস করে নিবি, কোনো অসুবিধা নেই, ঠিক আছে? বাট রাত্রি 12টার পর করিস না। ওকে, so this is my convolution layers, right? So I have applied, as I have told you, in convolution layers there will be filters will be applied, right? As I've shown you, like here, see how many filters were applied. 1 2 3 4 5 6, only 6 filters were applied, right? Only 6 filters were applied. But okay, but we are considering 32 layers, 32 filters, right? So 32 filters will be applied, and again my pools, then some activation function will be there. You don't have to understand for now. This is called ReLU function. This is similar to sigmoid but different than actually there is no curve in the graph. That's why. But you don't have to understand for these things right now. But yeah, this was activation function I have discussed, right? So now this is my input shape. Like I have to tell my model like what are the dimension I am taking, right? What a dimension should be taken in by when the model will be trained. I'm for generalizing, I'm considering 256 by 256 because the pictures will be different shape, right? Okay, just give me a moment if it's okay. Like if I show you an image of, okay, okay, leave it, okay. So some feature, some image will be taller, some image will be more wider. So For generalize every image, I am considering this value. This is my 256 by 256 value. And why I'm taking this 3? This is nothing but for the RGB value. RGB is means color photo, right? Then I am doing the max pooling layer for compressing in the first step. Then I am doing the convolution layer again. Now I am doing the now I am giving 64 layers or 64 filters, and the kernel size is 3 by 3. I have explained the things. What was kernel size? It will be applied in the whole image, right? The filter value, the matrix will be applied from first to end. Again there will be some activation function. Again there will be implementing max pool, max pooling layer. Again there will be one convolution layer. Now I am implementing 128 filters, right? The size of the kernel is 3 by 3. Now I am considering again one max pooling layer, and the spool size is 2. Don't worry about these things. You don't have to understand this for now. Now, after those, after everything, after every layering, what I am now doing? I am doing the flatten for vectorize every value, right? And this is nothing but just my neural network. Understand? This is my convolution part. This is my neural part. Okay. Okay. This is my neural network part. Now, for this, what I'm doing for now, this is my layer, hidden layer 1. Okay, let me 1, and this is my hidden 2, and this is my output layer. In the theory, okay, in the theory, I have discussed about why this thing is like only one neuron, right? This my first hidden layer has 128 neuron. Okay, my piece. You just give me a moment. And this for second hidden layer, I'm giving 64 neurons, and the activation function is ReLU. For let me just explain one thing for now. The ReLU is coming 2 times or 3 times. Just some visualization. What is ReLU actually is like if this thing is my sigmoid function, the ReLU is something different to sigmoid. This will be straight. Just understand these things only for now. If you want to explore things, then you might go and explore these things also. But I'm not going to explain these things for today. Okay, so this is my model architecture. Here we will not train our model. This is our model architecture. The model architecture, what our model architecture means, like what our model should be. That means, okay, this is our like format. One convolution layer, one max pooling layer, then one convolution layer, one max pooling layer, and the repetition. Like this is format. If any image comes, it has to be go through this format. Like next, right? That's why this called architecture, model architecture. Then we have to compile our model. Compile means we have to like for training we have to build our model. Okay, and model dot summary means okay, optimizer. I discussed about optimizer also. Optimizer is used in back propagation for weight updation, right? If you think what if you just go through my whole session, and if you understand the things, if you understand 1% of them, then you will be able to understand these things also. right? I know the neural network and convolutional network is very hard to understand, but yeah. But model summary, what means that means what is my parameters, what is my number of parameters. There is 14 lakhs parameter. Okay, 14 lakhs parameter. Okay, I have seen that, yeah, the previous session of Aunt Petal, you have seen like what is the tensor value, right? This is my tensor value, ultimate tensor value. If you don't know, okay, no worries. You don't have to worry about the tensor value. Okay, okay. Now I have to like you can make a variable, and to make this variable you have to like save your model. For that purpose, I'm just giving this like model.fit and saving this model here, right? You can also don't want, if you don't want to save your model, just model.fit trade data epochs means how many iterations should be circulate in the model, how many times the process will be running. One, two, three, four means for every image. Okay, okay, my computer is also lagging. And after that, you have to go with the model.evaluate. If you evaluate, it will be on the test data. That means whatever you have made, whatever you have trained your model, wha- how your model is performing on the test data. See, you have test data and train data, and how your model is doing in the test data will be here. And this is my accuracy, right? This is my accuracy, and this is my loss. Loss is high right now. I don't know why, but okay, okay. Something is like, see, in my last iteration, in my 10 number of epochs, my accuracy is 98%, and my loss is 0.341%. That means my loss is very less. As I have told you, the loss should be near to zero, right? So everything is come true now. The loss. Okay. Let me. Okay. This is to like, if you want to see whatever you have done, I have to do one thing. Okay, give me a moment. Hmm. Should be done. My laptop is also lagging. Yes. Keras dot models. Board model. Sorry guys. So lagging. Huh? Okay. Yes. Okay, guys. I forget to save my model. Sorry. No worry, guys. The input should be is ACC to enter image right? বল মাইক অন করে বল, কোনো অসুবিধা নেই। চন্দ্রেই
ওই যে পার্টটাতে তুমি ইনপুট শেপটা করেছিলে, তারাও ভুলে গেলাম পার্টটা, একটু স্ক্রল করো বলছি কোডটা।
আচ্ছা এটা তো
হ্যাঁ হ্যাঁ,
Hello?
ওখানে ফার্স্ট ইনপুট শেপটা
আচ্ছা
তো বেসিক্যালি
এইখানে করেছি কিন্তু
এর ভ্যালু, হ্যাঁ
XY
বলো।
কি বললি বুঝলাম না।
ইনপুট শেপটা
ইনপুট শেপ
তুমি
মানে
বলো,
হচ্ছে
ওখানে একবার দিয়েছো বাকিগুলো তো কেন বলনি, মানে দাওনি, একবার বলো।
আচ্ছা সি দেখ, আমি এটা বাংলাতেই বলে দিচ্ছি বোঝার জন্য। যখন তুই কনভলিউশন লেয়ারে ফেলবি একটা ইমেজকে, একটা ফিল্টার হবে, দেন ম্যাক্স পুলিং এ যাবে, কম্প্রেস হবে ইমেজটা, সেখান থেকেই ডেটাটা চলে আসবে যে নেক্সট ইমেজটা কম্প্রেস হয়ে কত এসছে, এইটা আমি দিয়ে দিচ্ছি। কিন্তু নেক্সট যেটা ম্যাক্স পুলিং এর ভেতর থেকে আসবে সেটা তো আমার হাতে নাই না, ওটা তো ও যেরকম করবে। ও যদি 3/, দেখ আমি এখানে 2/2 ম্যাট্রিক্স ইউজ করেছি, সো এরপর কেটে কুটে যেটা নিজে জানবে, আমি তো বুঝতে পারবো না, তাই না?
মানে ফার্স্ট টাইম ওটা ওই ইনিশিয়াল ইমেজটার ডাইমেনশন, ইনিশিয়াল ইমেজটা অনুযায়ী নিচ্ছে,
আমি তোকে
তারপর
একটা
ওগুলো
জিনিস
একটা
দেখাচ্ছি,
থেকে একটা জন্য নিচ্ছে।
এই দেখ প্রথমটা আমি বলে দিচ্ছি যে 256/256, তার জন্য এই রকম ছবি আসছে, ঠিক আছে, তিনটে ডাইমেনশন সেম, তারপর ম্যাক্স পুলিং হচ্ছে,
ল্যাগ
এরপর
তো ছাড়া আমি
সাথে
কিছু
কিছু
বুঝতে
নেই, তাই
পারছি
না?
না।
সরি এক মিনিট দাঁড়া।
আমার হচ্ছে না তোমার হচ্ছে সেটাও বুঝতে পারছি না।
হ্যালো
হ্যাঁ শুনতে পাচ্ছি।
শুনতে পাচ্ছিস তো? আচ্ছা ঠিক আছে।
হ্যাঁ হ্যাঁ
আমি
শুনতে পাচ্ছি।
বলছি সাপোজ মনে কর এই যে ফার্স্ট লেয়ারটা, এখন আমি ডিফাইন করতে পারি যে আচ্ছা 256 এরই ইমেজ তোমাকে করতে হবে, কারণ অনেক রকমের ইমেজ থাকে, কোনোটা 1080/720 থাকে, কোনোটা মানে অনেক রকম হাইট, অনেক রকম ওয়েটের ইমেজ থাকে, তাই তো, অনেক রকম মানে লম্বা চওড়ার ইমেজ থাকে। তো আমি একটা জেনারেলাইজ ফর্মের জন্য 256/256 নিচ্ছি, ঠিক আছে। প্রথম ইমেজ মানে প্রথম যখন ইমেজটা যাচ্ছে তখন আমি পারবো, আমি ডিফাইন করতে পারবো। নেক্সট টাইম যেটা কম্প্রেস হবে সেটা আমি করতে পারবো না, কারণ সেটা মানে কি বলবো, ম্যাক্স পুলিং এর
আচ্ছা
উপর
আচ্ছা
নির্ভর করছে
বুঝলাম।
যে সে কম্প্রেস করে কোন মানে কি ফরম্যাটে আনছে, ঠিক আছে। তো এই হচ্ছে ব্যাপার।
ওকে
তো
বুঝলাম।
তো যাই হোক, এইটা তোরা করিস, ঠিক আছে। দেন একটা কমেন্ট তোদেরকে করতে হবে, ঠিক আছে। আমি মডেলটা ট্রেন করতে মানে ট্রেন করেছিলাম কিন্তু সেভ করতে ভুলে গেছি, দ্যাটস ওয়াই আমি তোদেরকে এটা দেখাতে পারলাম না। আর সেভ মানে মডেলটা এখন ট্রেন করাও সম্ভব নয় আমার পক্ষে, নেটের একটু অসুবিধা চলছে। তো কি করবি, যখন মডেলটা তোদের হয়ে যাবে, ঠিক আছে, তো তখন একটা কমান্ড করবি model.save, তোরা যে নামে সেভ করতে চাস। কিন্তু একটা জিনিস মনে রাখবি, .h5 শুড বি দেয়ার। এটা হচ্ছে মডেলের ফরম্যাট, অনেক রকম ফরম্যাট হয়, তাই না, যে .jpg হয়, .png হয়, ঠিক আছে। তাই জন্য মডেলের যে কনফিগারেশন সেটা .h5, তো এরকম করে সেভ করতে পারিস মাই model.h5। এটাকে তোরা অবশ্যই সেভ করিস, কারণ এইটা তোদের নেক্সট সেশনে লাগবে ডেপ্লয়মেন্টের জন্য, যেটা কাল হবে, ঠিক আছে। তোরা অবশ্যই সবাই নিজেদের মডেল সেভ করবি, তাছাড়া কিন্তু করতে পারবি না, ঠিক আছে। এই কোড বেস আমি তোদেরকে দিয়ে দেবো, ডেটা সেট তোদের কাছে আছে, কোনো অসুবিধা হলে রিচ আউট করিস, কোনো অসুবিধা নেই, ঠিক আছে। যেখানে বুঝতে পারবি না কোডে বলবি, আমি বুঝিয়ে দেবো, কোনো অসুবিধা নেই, ঠিক আছে। সো এটাই হচ্ছে আমাদের আজকে শেষ, ঠিক আছে। তো আমরা আশা করছি অনেক কিছুই দেখলাম আজকে। ডিউ টু মাই নেট কানেকশন আমি একটু বুঝতে পারছি যে প্রবলেম হয়েছে, ভয়েস ক্র্যাক করছে, একটু কষ্ট করে নে, আর কি করবো বল। আমিও খুব চাপে পড়ে গেছি আজকে, তার মধ্যে ঝড় বৃষ্টি হচ্ছে। অরুণিমা হয়ে গেছে, চলো দেখে নাও। 1.5 ঘন্টা সেশন করবো।
Thank you so much, Orkoda, for today's session. আর যাওয়ার আগে সবাই প্লিজ ফিডব্যাক ফর্মটা ফিল করে দিয়ে যাস।
সবাই
থ্যাংক
চুপচাপ
ইউ
ভালো
সো
দিবি, কোনো কিছু যায় না। যাই
ফিডব্যাক
হোক,
ফর্মটা প্লিজ।
একদম। চলো,
Thanks for joining in, everyone. Please feedback form to fill up করে দিন. It's in the chat, and we'll also share it in the WhatsApp group after this session.
ওকে, বাই দ্য ওয়ে কেমন ছিল
Okay, okay, okay,
এমনিতে?
okay.
আরে জামিরুল,
One second.
জামিরুল কোথায় গেল? চলে গেল, চলে গেছে। পারমিশন নট গ্রান্টেড, ভালো ছিল। আচ্ছা, না দেখ দেখ, আমি চেষ্টা করেছি জিনিসগুলোকে অনেক ভালো করে ইজি করে বোঝানো। তো চিন্তা নেই, থার্ড ইয়ারে এসব কিছু নাই, মানে আছে অনেক কিছুই, কিন্তু কিছু নাই, মানে এত কিছু কেউ বোঝাবেও না। ঠিক আছে,
সিদ্ধান্ত আরেকবার রিফ্রেশ করে দেখ, এবারে ফিল আপ করতে পারবি।
একদম একদম। সিদ্ধান্ত যখন, আমরা তো সেকেন্ড ল না, থার্ড ইয়ারে
আরে
আছি।
আই থিঙ্ক এটা এন্তিকা বলছিল। হ্যাঁ,
কে বলছিল? বেশ
আমার এবার থার্ড।
প্রবলেম হচ্ছে। এমনিতে আমার নেট আজকে যা দিয়েছে,
ऐसे बड़े बड़े इवेंटों में ऐसे छोटे छोटे चीजें होती रहती है। আর কি বলো?
সেই যাই হোক,
হ্যাঁ, আজকে বৃষ্টির জন্য সবার ইন্টারনেটে জ্ঞান করবে।
হ্যাঁ, আর আমার তো মোবাইল ইন্টারনেট আরো জ্ঞানাকুল, আমার জীবনটাই জ্ঞানাকুল হয়ে গেছে। যাই হোক, চলো, টাটা, গুড নাইট। ঠিক আছে,
গুড নাইট।
আমি আমার
থ্যাংক ইউ সো মাচ।
স্ক্রিন
গুড
শেয়ারিং
নাইট।
অফ করলাম। ওকে, লিভ করলাম।
ওকে, থ্যাংক ইউ দাদা।
Bye bye, everyone. Good night.